Okay, in this video we're going to look at 12.2, which is Rectilinear Kinematics, continuous motion. Let me just bring the textbook here. So we're going to look at this, Rectilinear Kinematics, continuous motion. So just a quick point, what is rectilinear? That just means straight line. Again, what is kinematics? It means we're just studying the motion of a particle. We're studying the position, the velocity, and the acceleration. Okay? We're not studying in this chapter what causes the acceleration. We are just looking at the motion. And in this case, in 12.2, we are looking at continuous motion. Okay. So again, rectilinear. Just wait for this to. Rectilinear is straight line. We're looking at straight line. So a particle just moves in a straight line. Okay, just like that. So straight line motion. We've already seen what kinematics is. Kinematics is only looking at the motion of the particle. Okay, which means we're looking at the position. That S is defined by position, velocity, and acceleration. Okay. And then the reason why we say continuous is because we're going to see in this section 12.2, if we draw a curve of, say, the position time, okay, and we'll get to this now, so don't worry, we'll get to this now. If we draw a curve of position time, for example, okay, it will have a continuous function like this. Okay, so from the beginning till a specific time, we have just one function. So that just means continuous. Okay, we'll see in 12.3, we'll see something slightly different. Okay, so now let's look at the kinematics. Let's look at the kinematics. What did I say here? We have position, velocity, and acceleration. The position, velocity, and acceleration describe the motion of the particle, which means we're studying the kinematics. So let's look at position. Okay, if we have the origin here, and there's a straight line, okay, the position, number one, it's a vector, right? And seeing as we're looking at just a straight line, if there's our origin, then anything to the right is positive S. Okay, so what does the position do? It simply defines where it is in relation to some reference point. So this position, for example, could be 10 meters, right? It could be 10 meters. And then we have another, say there's another position, say the particle moves from there to there. Then that could be, say that's S1 and S2, that could be 20 meters. All right, so the position is literally just telling us at any time, at any point in time, what is my position at that moment in reference to some reference point. So at this time, I'm 10 meters from there. At that time, I'm 20 meters. Okay, so it's a vector. If the particle was to this side of my origin, say that's S3, equal to, and that length was, say, 5 meters, then it would be -5, because position is a vector. So anything to the right would be plus, anything to the left would be minus. Okay, the next thing we want to look at is displacement. We want to look at displacement, and let's have a look at this example here. Displacement is just the change in position. It is my final position minus my initial position. It is also a vector. Please take note of this, guys. It is only the change in my position. Okay, so we'll do an example now, but let's have a look at say this position 1 and position 2. What is my change in position or my displacement? What is my final? It'll be S2 minus an initial, which is S1, which is 20 minus 10 which is 10 meters. Okay, plus 10 meters. So it's a vector, so it means the change in position, my displacement, increased. It moved in that direction. Okay, so my change in S is that. What if I said change in S between S1 and S3? What would we have then? What about change in position between S1 and to S3? It would be position 3 minus position 1. Okay, so what is position 3? Position 3 is minus 5. And what is position 1? Position 1 is 10. Position 3 is minus 5. Remember, these are vectors. You have to take into account the direction. Minus 5. Minus, what is S1? Plus 10. So that was 10. So we're going to have minus 5 minus 10 equals minus 15 meters. That's my change in position. Does it make sense? That was my beginning position. I moved minus 15 to get to position 3. Okay? Now, I'd like to talk about distance. Distance traveled. Okay? This is given by ST. So position, I'm sorry, I didn't even mention this. Position is given by S. Okay? And displacement is delta S, and distance is ST. Now, the distance is a positive scalar. It's a positive scalar. What does it mean? It means we don't consider, let's just do an example to explain. So, say now we started here at position 1, we moved to position 2, we turned around, and we moved all the way to position 3. Okay? Started, that's our beginning position. We moved there, and we came all the way back. What would our displacement be? Well, we just calculated it. Our displacement is the change between the final and the initial. The final and the initial, which was S3 minus S1. Okay? So, and that is a vector, so we had to take into account the sign. The distance is literally, how far did you walk? I walked there, from that point to there, which was 10 meters. Then I turned around, I walked another 10 meters to get back there, and then I carried on walking another 15 meters. All right? Walked there, and I came back. And all we do is we add up those distances. 10 plus 10 is 20. So ST is 10 plus 10 plus 15, right? 10 plus 10 plus 15, which is 20 plus 15, which is 35 meters. Notice, it is a positive scalar. We are not concerned at all with the directions. We are looking at the magnitude of this length. So we're calculating the total path that this particle moved, which was 10 plus that entire distance. Okay? So please make sure that you understand what's the difference between position, displacement, and distance. Okay, we'll stop there.